Determine the empirical formula of adrenaline, which contains 59.0% carbon, 7.1% hydrogen, 26.2% oxygen, and 7.7% nitrogen, with molar mass 180 gram per mole. So, the various compositions. So, we have carbon, hydrogen, oxygen, and then nitrogen. The percentage composition of each of them. For carbon, it is 59%. Hydrogen is 7.1%. Oxygen is 26.2%. And then nitrogen is 7.7%. So you take each of them and then divide by their atomic masses. So hydrogen is 7.1 divided by 1. Oxygen is 26.2 divided by 16. And nitrogen is 7.7 divided by 14. So 7.7 divided by 14 is 0.55. And then 26.2 divided by 16 is 1.64. And for hydrogen, it's here 7.1. And for carbon, 59 divided by 12, that is 4.92. So you take the smallest, which is 0.55, and divide through. So here 0.55 divided by 0.55, and that is 1. 1.64 divided by 0.55, and that is 2.98. And 7.1 divided by 0.55, and this is equal to 12.9. And here's 4.95 divided by 0.55, and that is equal to 8.95. So if we round it up to the nearest whole numbers, see that here is 9. Then 12.9 will give 13. Then 2.98 is 3, and then 1. So what does it mean? This means that the empirical formula of adrenaline is equal to C9H13O3 and then N. This is the empirical formula of adrenaline. Then now, they give us a molar mass of 180 grams per mole. So we can go ahead and find the molecular formula. So the molecular formula is equal to C9H13O3N times N, small n. So let me put a small n here. So carbon is 12, so 12 times 9, plus hydrogen is 1 times 13, plus oxygen is 16 times 3, plus nitrogen is 14, so plus 14 times n equals what was given us, which is 180 grams per mole. So 12 times 9 is 108, and plus 1 times 13 is 13, plus 16 times 3 is 48, and plus 14 n equals 180. So 108 plus 13 plus 48 plus 14 is equal to 180, n is equal to 180. So if you divide through by 180, divide here through by 180. So you find out that n is equal to 1. This implies that the molecular formula of adrenaline equals the empirical formula of adrenaline, and that is equal to C9H13O3N. So this is the molecular formula of adrenaline. The beta blocker drug timolol is expected to reduce the need for heart bypass surgery. Its composition by mass is 49.4% carbon, 7.6% hydrogen, 17.7% nitrogen, 15.2% oxygen, and 10.1% sulfur. The mass of 0.1 mole of timolol is 6.32 grams. What is the empirical and molecular formula of timolol? So the various elements are carbon, hydrogen, nitrogen, oxygen, and then sulfur. So the percent composition of carbon is 49.4%. Then hydrogen is 7.64, nitrogen is 17.7, oxygen is 15.2, and then sulfur is 10.1%. So as usual, you take each of them and divide by their various atomic masses. So in the case of carbon, it's 49.4% divided by 12, 7.64% divided by 1. Nitrogen is 17.7% divided by 14. And here's 15.2% divided by 16. And sulfur is 10.1% divided by 32. So in the case of sulfur, we get 0.316. And 15.2 divided by 16 is 0.95. 17.7 divided by 14 is 1.264. Then 7.64 divided by 1 is 7.64. And 49.4 divided by 12 is 4.117. So you take each of this and you divide by the smallest. The smallest here is 0.316. So here's 0.316 divided by 0.316. And this is equal to 1. 0.95 divided by 0.316 in this case, and this is 3.00. Then 1.264 divided by 0.316, and that is equal to 4.00. 7.64 divided by 0.316, and that is equal to 24.18. Then we have 4.117 divided by 0. Let me write it well. Let me write it here. Just 4.117 divided by 0.316, and that is equal to 13.03. So let's round it off to the nearest whole number. Here's 1, here's 3, here's 4, here's 24, and then here's 13. And therefore, the empirical formula of timolol is C13H24, then nitrogen N4, oxygen is 3O3, and then sulfur is 1S. So this is the empirical formula of timolol. However, they said that 0.1 mole of 6.32 grams. So what we need to do is we need to use this information. The number of moles of timolol is 0.1 mole, and then the mass of timolol is 6.32 grams. I will know that molar mass is equal to mass over number of moles. So this is equal to 0.1 divided by 6.32 grams. And this is equal to 632 grams per mole. There is a mistake here. Here is 0.01 mole. So here is going to be 0.01 mole. And that is equal to 632 grams per mole. So the molecular formula in this case, MF, is equal to, into bracket, C13H24 N4O3SN. So let's do it here. So for timolol, we got the empirical formula as H24 N4O3S. So the molecular formula is equal to the empirical formula times a certain constant, so which is C13, H24, N4O3S times N. So let's go ahead but we got the molar mass as 632 grams per mole. So let's go ahead and find the value of N. So that is C13, H24, N4O3S times N is equal to 632 grams per mole. So carbon is 12. Here's 12 times 13 plus hydrogen is 1 times 24 plus nitrogen 14 times 4 plus oxygen 16 times 3 and plus sulfur, which is 32 times N is equal to 632. So 12 times 3 is 156 plus 24 plus 56 plus 48 and plus 16 times 3 is 48, then plus 32 times N is equal to 632. So 156 plus 24 plus 56 plus 48 plus 32 is 316 N is equal to 632. So you divide through by 316, you divide here 2 by 316. So 632 divided by 316 is 2. So N is 2. This implies that the molecular formula is equal to C13H24 N4O3S times 2. And therefore, this is equal to C 2 times 13 is 26. Then H 24 times 2 is 48. Then nitrogen N 4 times 2 is 8. Then O3 3 times 2 is 6. So 6. Then sulfur was 1. 1 times 2 is 2. So this is the molecular formula of timolol. Captopril is a drug used to treat heart disease. Its composition by mass is 49.4% carbon, 7.64% hydrogen, 15.2% oxygen, and 10.1% sulfur. The mass of 0.01 mole of captopril is 3.16 grams. What is the empirical and molecular formula of captopril? The elements are carbon, hydrogen, then we have oxygen, and then sulfur. So what are their percentage compositions? Their percentage composition of carbon is 49.4%. Then for hydrogen it is 7.64%. Then oxygen is 15.2%. And then sulfur is 10.1%. So the next step is take all their percentage compositions and divide it by their various atomic masses. So here will be 49.4 divided by 12, and then 7.64 divided by 1, 15.2 divided by 16, and 10.1 divided by the atomic mass for sulfur is 32. So this is equal to 4.12, 7.64, 0.95, and 0.32. The next step is divide through by the smallest value among all the four. So that will be 0.32 divided by 0.32, then 0.95 divided by 0.32, and 7.64 divided by 0.32, and then 4.12 divided by 0.32. So 0.32 divided by 0.32 is 1. Is 1. And 0.95 divided by 0.32 is 3. And then 7.64 divided by 0.32 is 24. Sorry, I made a mistake. 0.32 divided by 0.32 is 1. 0.95 divided by 0.32 is 2.969. Then 0.64 divided by 0.32 is 23.875. 0.412 divided by 0.32 is 12.875. So in rounding it off to the nearest whole number, this part becomes 13, and here becomes 14, and here becomes 3, and here remains 1. So therefore, the empirical formula of the compound is the number of carbons there are 13, the number of hydrogens are 24, the number of oxygens are 3, and the number of sulfur is 1. So C13H24O3S. The second part of the question says that the mass of 0.01 mole of captopril is 3.16 grams. What is the empirical formula for captopril? So since we know the number of moles of captopril, and we also know the mass to be 3.16, we know that the molar mass of captopril is equal to the mass of captopril then divided by the number of moles of captopril. So let's go ahead and compute that. So this is equal to, the mass is 3.16, and then the molar mass is 0.01. So the molar mass of captopril, and the number of moles is 0.01. So 3.16 divided by 0.01 is 316 grams per mole. So this implies that the molar mass of captopril is 316 grams per mole. So how then do we find the molecular formula? So the molecular formula, let me continue from here. The molecular formula of captopril is equal to C13, let me put it in bracket, H12, H24, O3S times a certain number n, for which the value of n multiplied by the sum of the molar masses of the various individual elements equals 316 grams per mole. So this means that I'm opening a big curly bracket. The atomic number of carbon is 12, 12 times 13, then plus 1 times 24. So plus, let's say plus 1 times 24 plus oxygen is 16 times 3, and plus sulfur is 32, and times n is equal to 316 grams per mole. So in summation, this is equal to 12 times 13 is 156, plus 1 times 24 is 24, plus 16 times 3 is 48, plus 32. All of this multiplied by n equals 316. So if you sum all of this, you will get 260. N equals 316. So this implies that n is equal to 316 divided by 260. So since n is equal to 1.2, we can round it to the nearest whole number so that n is equal to 1. And since n is equal to 1, it means that the molecular formula is into bracket C13 H12 H24 O3S times 1. So 1 multiplied by this will give us a molecular formula which is equal to the empirical formula. So the molecular formula is also equal to C13 H24 O3S. Determine the empirical formula of a compound with the following composition by mass: 60.0% carbon, 8.0% hydrogen, 32.0% oxygen. If 100 milligrams of this compound is neutralized with exactly 10 mils of 0.05 molar sodium hydroxide in a reaction with a stoichiometry of 1:1, what is the molecular formula for this compound? So the compound is CHO, and then the composition of carbon is 60.0%, then hydrogen is 8.0%, then oxygen is 32.0%. So the next thing is take the various percentage composition and divide by their relative atomic masses. So 60 divided by 12 for carbon, 8 divided by 1 for hydrogen, and 32 divided by 16 for oxygen. 60 divided by 12 is 5. 8 divided by 1 is 8, and 32 divided by 16 is 2. So this implies that the empirical formula for the compound is C5H8 and then O2. So this is the empirical formula for the compound. The second part of the question says that if 100 milligrams of the compound is neutralized with 10 mils of 0.05 molar sodium hydroxide in a reaction, which is 1:1, what is the molecular formula of this compound? So first, let's calculate the number of moles of sodium hydroxide. So the number of moles of sodium hydroxide is equal to the concentration of sodium hydroxide times the volume of sodium hydroxide. So we are given concentration as 0.05 mole per decimeter cube, and then the volume is 10 mils, and 10 mils is the same as 0.01 decimeter cube, and therefore the number of moles of sodium hydroxide is 0.0005 moles. Then now, since the stoichiometry of reaction is 1:1, it means that the number of moles of sodium hydroxide is equal to the number of moles of the compound, and therefore the number of moles of this compound, which is C2H8O2, is equal to 0.0005 mole. Now, since we have the number of moles, we can calculate its molar mass. So molar mass of the compound is equal to the mass of the compound divided by the number of moles of the compound. So the mass of the compound was given as 100 moles, 100 milligrams, and then 100 milligrams is the same as 0.1 grams divided by the number of moles, which is 0.0005 moles, and therefore this is equal to 200 grams per mole. So we know that the molecular formula is equal to C5H8O2 times N. So C5H8O2N should be equal to 200 grams per mole, and therefore this implies that carbon has atomic mass of 12 times 5. Then plus hydrogen is 1, so 1 times 8. Then plus oxygen is 16, 16 times 2 times n is equal to 200. So 12 times 5 is 60, plus 1 times 8 is 8, plus 16 times 2 is 32. All of this times n is equal to 200. And 100 n, sorry, here 60. So 100 n is equal to 200, and therefore n is equal to 2. So since n is equal to 2, it means that the molecular formula of the compound is equal to C5H8O2n, which is equal to C10. So 5 times 2, sorry, n is 2. So 5 times 2 is 10. H, which is 8 times 2 is 16. Then O2. So O is 2 times 2 is 4, so it becomes O4. So molecular formula of the compound is C10H16O4.